So today we're going to be going over geometric sequences, and it's similar to arithmetic. If you remember arithmetic, there was a common difference. Arithmetic, you were trying to notice what number you're adding from one term to the next. But if you were to do a geometric sequence, we have what is called a common ratio. It is the number that you're multiplying to get from one term to the next throughout the whole sequence. So the way in which we would find R is to find a sub 2 over a sub 1, or a sub 3 over a sub 2, a sub 4 over a sub 3. It has to be consistent, okay? In order for it to actually be called a common ratio, it has to be the same ratio throughout the whole sequence. It can't just work for the first two terms and not the other ones. Okay, it's got to work for the whole thing. Okay, so that's why it says here find the common ratio, and you may already be looking at it and identifying it, but I want you to write it down, and that's what we're going to do together for these four problems. Okay, so for number 1, we had 2, 4, 8, 16. This is an infinite geometric sequence, and we want to find the common ratio. So you can see that you're multiplying by 2 throughout, so that means that R is 2. In number 2, we have 12, 36, 108, 324, and so on. So another infinite geometric sequence, and you can see that we're multiplying by 3, and if you were to work this out between 36 and 108, it is indeed 3. So number 3, again, you may not see your common ratio off the bat, and that's why I showed in the last one in number 2. You can just divide two terms and to see what your common ratio is. So in number 3, if you take negative 1/2 and you divide it by 1, obviously it's negative 1/2. But 1/4 divided by a negative 1/2 is also negative 1/2. Where's my negative? There it is. So R in this case is indeed negative 1/2. So that's how you can find it. Same thing with number 4. Running out of space, let me squeeze it in here. So we have, make sure you write this one out. So for number 4, we had negative 1/3, 1/9, negative 1 over 27, 1 over 81, and so on. So if you were to take the 1/9 and divide it by the negative 1/3, I'm sorry, I have to write it like this to squeeze it in, we get negative 1/3. Okay, you may be able to see that, but I'm just showing you how you could get the common ratio. This is supposed to be 2. Now, between the third and second term, it's still negative 1/3. So for number 4, R is negative 1/3. Okay. Okay, so this is the formula proven to work to find the nth term of a geometric sequence. And what it does is it uses the common ratio, and it's being multiplied with possibly some sort of constant, which could turn out to be a sub x. I say could turn out to be. It is. And there is an exponent. If you remember through the very first lesson, we went through many, many different types of sequences. I didn't want you to get used to all the names. But one of them, if you were to multiply by a number throughout the sequence, we can use that as R, and we could do n minus a number or plus a number, adjust the exponent to get a sub n. And there were times in homework problems where we need to multiply it by some sort of number in order for it to work precisely with our sequence. So that is true. This is exactly why the formula works. Now, if you have two terms, okay, we call it n and x, then that's what's giving us our expression with our common ratio. This would divide out instead of subtract out, and that's how we actually find our common ratios through division. So it kind of holds true for this formula, and it's kind of necessary throughout all of our questions. So in this particular problem, in example number 1, it's pretty simple. It's just to find the nth term of the geometric sequence, and we're given 2, 4, 8, 16, etc. So we already know that the common ratio is 2. We can kind of see it throughout the problem. We already went over that in the last example group. So since r is 2, okay, and we need the n term of the sequence, we're going to leave the n there. We need something for a sub x. It could be anything that we see in our sequence. So if we want it to be the last term that we see, we notice that is the 4th term. So this is going to be 2 to the n minus 4. So a sub n is going to be 16, okay, times 2 to the n minus 4 power. Many of you are very commonly used to working with the first term. So if I use the first term, this is going to be 2 to the n minus 1 power. It turns out that if we simplify these two expressions, they turn out to be the exact same thing, which is exactly what we would have written on our very first day. If we were to write out a formula on the very first day, we notice we're multiplying by 2. We have 2 to some power of n. If we left it like this will work exactly to every term in our sequence. Okay, so if you were to take notice, 2 to the first power, same base, you can combine the exponents, so you end up with just n by itself there. And 2 to the 4th power is actually 16, and 4 plus n minus 4 is just n. So once again, they combine to give you that same formula. So that is why we were able to actually see different ways of writing a sub n, and it gives us the same sequence that we're looking for. So it is quite possible you can do that for a problem like this. Please just make sure you follow through with that formula, no matter which way that you do it, so I can follow to see if you're using the right term in the right places. All right, so off to the rest of the practice.